looking at section 2.2 then, and we're looking at other measures of location. So location, remember, is to give you the idea of, if you picture all the data on the number line, whereabouts is it? Just is it near 0.1? Is it near 20? Is it near 5 billion? What sort of numbers are we looking at on the number line? And that's the idea of a location. Roughly where on the number line are we? Now, the usual ones that we use are mean, median, mode, and they are, in the previous section, described as measures of central tendency. We usually call them averages. The idea is that they should be somewhere in the middle of the data. And you're probably familiar already with the idea of lower quartiles and upper quartiles. So quartile, like quarter, splits the data into 4 equally sized pieces. Now, this diagram that we've got here is a pretty good one, but we've got to be a little bit careful. The lowest value, then you get the lower quartile, the median, which we're going to call Q2, upper quartile Q3, and highest value. These 25% here represent 25% of the data. So a quarter of the data will be between the lowest value and the lower quartile, a quarter between the lower quartile and the median, and so on. But the way that this is drawn on the diagram sort of gives you the impression that if you were to picture all the data on the number line, then you could find the lowest piece of data, the highest piece of data, and the median and the quartiles would be evenly spaced out between them if this was a number line. Now, if this was a number line, that wouldn't necessarily be true, would it? You're much more likely to get this sort of shape with a lot of data, which if we turn it into a box plot, you might be familiar with. Okay, so the median, you're likely to have a lot of data near the median, so the lower quartile and the upper quartile aren't too far away from the median, but the gap between the upper quartile and the highest piece of data and the gap between the lower quartile and the lowest piece of data are bigger, so this would be our normal distribution kind of curve, or our bell-shaped curve. We haven't officially met the normal distribution idea yet. So near the average, the average is where most of the data is, and near the average is where most of the data is, and the further away you go from the center, the fewer pieces of data you've got. So there's a few, if this was height, a lot of people are at near average height. You've got a few tall people, you've got a fair number of tall people, you've got a fair number of short people, you've got a few very tall people and a few very short people. And the further away you go from average height, the smaller it is. And this is my drawing. This is supposed to be a symmetrical sort of bell curve. So that is what, it's called the normal distribution because a lot of data follows that sort of shape. The whole point of that is just to give you the idea that these quartiles, this is a good diagram to get the idea, 25% of the data here, 25% here, 25% here, 25% here. But the regularity of this spacing is nothing to do with the number line, okay? There's no reason that the distance between the lowest piece of data and the lower quartile should be the same as the distance between the lower quartile and the median, just that 25% of the data lies here, 25% lies here, and so on, okay? Now, if we're dealing with discrete data, you'll be familiar with this sort of idea, that if I have, let's say, 1, 1, 3, 7, 12, there's my 5 bits of data, the median would be 3, wouldn't it? Okay, so it's a piece of data that's in the middle when you put it in order. But if I had 4 bits of data, 1, 1, 3, 7, then the median would be halfway between 1 and 3, so the median would be 2, okay? So if we've got an odd number of pieces of data, so there's 5 pieces of data here, any odd number, the median is going to be the piece of data in the middle. If we've got an even number, so this is 4 pieces of data, there isn't going to be a piece of data in the middle, so you're going to have to find the 2 pieces of data in the middle and find halfway between those two. Okay, so this is just, Key Stage 3 or GCSE finding the median if you've got a list of numbers. Now, that, strictly speaking, is totally correct, but if we're doing statistics and we've only got 5 pieces of data, it's a bit of a funny situation in the first place. Why bother finding an average if you've only got 5 pieces of data? The point of an average is to have one number to represent the whole data set. If there's only 5 pieces of data in the data set, you can probably just look at a list of 5 numbers. So if you're going to do the statistics in the first place, if you're going to find measures of central tendency and spread and all that sort of thing, you need a good-sized data set. You need a lot of numbers. And if you've got 30 numbers in a row or 500 numbers in a row, then worrying about the difference between, if say you've got 500 numbers in a row, worrying about the difference between the 250th number and the 251st number is probably not all that important. They're probably quite close together. So what we'll often find is in a lot of the questions, when we've got a large n, when we've got a lot of pieces of data, the median, it will say if we've got 50 pieces of data, the median is piece of data number 25. We won't worry too much about finding halfway between 25 and the 25th and the 26th pieces of data. We'll just half n, and that's where we'll look for our median in a lot of cases. Now, if you look, we'll get onto that in a moment, and we'll see exactly the rules for when we just half it and when we don't. Similarly, though, with the quartiles, just quickly, if you've got n pieces of data, if n is an odd number, then you add 1 and half it, and that tells you where the median is. So there's 5 pieces of data here, that's an odd number, add 1 to 6, half it, and that means the third piece of data is the median, which in this case happens to also be a 3, doesn't it? If you've got if n is an even number, here we've got 4 pieces of data, add 1 and half it, that gives us 2.5, so halfway between piece of data number 2 and piece of data number 3, that's where we look for our median, okay? Now, with the quartiles, there are similar rules, and you could probably work out the rules for yourself, but these are the rules that we're going to follow for the exam board, so there's no need for me to read those to you. You can read them for yourself. Don't be tempted to devise a new set of rules that you think is sensible and follow those, because sometimes you might find they come up with a different answer to this set of rules here. Just go with this set of rules. In real life, of course, if you're looking for the lower quartile and the upper quartile, firstly, you should have enough data so that it doesn't really matter whether you're looking at one piece or the next piece. You should have enough data that, the 70th and the 71st piece of data are so close that you don't really mind about the difference. And also, you can make up your own rules as long as you've got a sensible rule. There's a lot of things in this book which are conventions that we have to follow. Some of those are conventions that are sort of universally followed, and some of them are conventions for this exam board and for this textbook and for our exam. So in this case, with lower quartile and upper quartile, there's no real problem in general, but this is the method that we've got to follow in order to find those things. So make sure you know those ones. Interquartile range, of course, is the highest, is the upper quartile take away the lower quartile. And this pink box here, I draw your attention to, for grouped continuous data or data presented with the cumulative frequency table, we always just half n for the median, a quarter of n for the lower quartile, 3/4 of n for the upper quartile. So that's when we do that. If we've got discrete data or a list of data like this, which to be honest doesn't happen very often in the exam, but it could happen, then these are the rules that we follow, okay? So make sure you're paying attention to that one. Now, the next topic in this section is interpolation, and I think we'll put that in a separate video because it's such a tricky one.